Welcome to solverfy.
So here in this problem we have to calculate the smallest horizontal force P that must be applied to the lever to stop the wheel, and we are given that the coefficient of kinetic friction between the wheel and the band is 0.3 and the wheel is subjected to the torque of 50 Newton meter. So this is what we are given in the question. Now to solve this problem we'll be first drawing the free body diagram of the wheel. So this is the free body diagram of the wheel, and here we are assuming that T2, the tension T2 is greater than the tension T1. Now by using the tension in the belt, using the concept of tensions in the belt, we can calculate the relation between T2 and T1. So T2 will be equals to T1 times e to the power mu k into theta, and in this case theta would be 270 degree, that means 3 pi by 2. So from here we'll get the expression for T2 as T2 is equals to T1 times e to the power mu k, we have 0.3 times 3 pi by 2. Now let us calculate the moment about point E. So we can write that minus T2 times 0.15 meter, this is the radius, plus T1 times 0.15 meter plus m is equals to 0. We have taken the moment in the anti-clockwise direction to be positive, and in the clockwise direction we have taken it to be negative. So we can plug the value of m here, and we know m is 50 Newton meter. So we'll get the value as minus T2 0.15 meter plus T1 times 0.15 meter plus 50 Newton meter is equals to 0. So we have two equations, this, and we have two variables T2 and T1. By solving these two equations we can calculate T1 and T2. So we'll get the value of T1 as equals to 107.14 Newton, and we'll get the value of T2 as 440.47 Newton. Now next we will be drawing the free body diagram of the link. Now this is the free body diagram of the link. Now we have calculated this T1. Now we can calculate the value of force F which is acting by taking the moment about point B. So we can write sigma mb should be equals to 0. So from here minus T1 times this distance is 0.05 meter, 50 mm means this much of meter, minus F times 25 mm means 0.025 meter, it should be equals to 0. And we can plug the value of T1 here. T1 we have calculated as minus 107.14 Newton. So from here the value of F comes out to be as minus 214.28 Newton. So we have calculated F. Now next we have to calculate the value of P actually. So for that we'll be making the free body diagram of the lever. Now this is the free body diagram of the lever. Now our aim was to calculate this value force P. So for that we can take the moment about point A. So minus P times this distance is 0.4 meter minus F times this distance is 100 mm, that means 0.1 meter, and it should be equals to 0. We can plug the value of F here. So minus P times 0.4 minus F, we have minus minus will become plus 214.28 Newton times 0.1 is equals to 0. From here the value of P comes out to be as 53.6 Newton. Therefore this is the required smallest force to stop the wheel. So I hope you have understood the problem. Thank you.